Hello, this video is for explaining the ColorLab software. ColorLab software is a tool for optimizing the spot color reproduction in one device. The software works under PC and under Mac, and it's 64 bits. It's optimized for the new MacOS Maverick version, also supporting the black mode and so on. First thing we need to get it's an LED color that it's get it here. You can type the color number manually, for example 45 10 25, and here you have the LED. If you want to delete this value, you can click in dull, and it's going always to the default value 100. Second way of entering colors, entering LED values, is by measuring. Here it's detecting the I1 that I have connected, and here pressing this button I will do the calibration. I need to put the I1 over the white plate, and when I click in OK, the I1 will be calibrated, and then I can start taking measurement. For taking a measurement, I can click on this button. This will measure and this will be, for example, the LED of the white base, or I can go with my I1 over one surface and just clicking the button of the instrument, and then I get the measurement of this value. The third way of entering LED values is by browsing into swatches. Here we have several libraries, HKAs, Ampere, DIC, Pantone, Colors, Toyo, and so on. So if you select one library, here you have all the colors of the library, and you just need to select the color that you want, and here you have the LED. For example, if I want to go into the Pantone solid coated, here I have all Pantone solid coaters, dark blue, medium purple, pink. If I want to search a given value, for example, whatever Pantone that contains 340, here we have all the Pantones in the naming I have 340. If you delete it, you have the full list. For example, if I want to go to Pantone medium purple, here you have the LAB of Pantone medium purple. This LAB is converted into CMYK values in this case. Into CMYK values, because I have selected here in my printing mode CMYK, and here I have the list of my profiles in my user folder. I can search for the profiles in my system folder or in my user folder. In a PC, I will switch between the system folder and my ColorGate production server folder. If I select one profile, for example, let's go for one standard profile like Seagate's condition 6, then here this is the CMYK value that I will get in Seagate's 21 when I try to print Pantone medium purple through this rendering intent, because I can here take the rendering intent, and if I change the rendering intent I get a different number, and this number it's converted back through the profile, so I get here the LAV that I will get. So this is the LAV that I'm trying to get, and this is the LAV that I will really get when I will send this number into the device. And here I have the delta E, or the difference in color between the color that I'm trying to print and the color that I will print. I can switch between different delta E algorithms, so I can look at these values in different ways. Let's go for delta E 2000 in graphics, that is the default one. Okay, you can go through a relative colorimetric, you will get different number, saturation, a different number. Of course, you supported black point compensation, so you can see the differences between the black point and a black point. And you can look always to the numbers, and if you go with an absolute colorimetric, you will get the lowest value that you can get always, because it's considering it's trying to get this color as with the minimum possible distance. Okay, you can play with these numbers, so you can type your number, and if you believe that instead of 7 of black, put in 5 of black, you will get a better number, you can type it, and then here you will get the LEV that you will get, and this is the LEV that you are going to get if you send this number. So if you, for example, send 100,000. This is the LAV of 100,000. And of course this LAV, it's 54 delta A's over the value that I want to get. And this is the LAV of the value that is converted through ICC. And this is the LAV that I'm getting if I use a manual input. If I switch off this, these two columns are equal. So this is in the bottom area, the LAV that I can get manually, and this is the LAV that will be getted through standard color management. I can go through RGB profiles, also whatever RGB profile, and I can see here the numbers. Again, I can play with these numbers manually, or I can go with multi-channel. Of course, here I'm getting the colors of my device, the primary colors. So if I go with this profile here, these are the colors of my profile. And if I go with the Jetmaster 6 color Chemi, these are the colors of my Jetmaster. And this is the delta A that I will get when I'm trying to print this value here. Okay, this gives me the first important feature here. That is that I can type whatever number, for example 0000100, and get the LAV that I will get on real time and the color. And if I mix it with 50% of magenta, then I will get this LAV, and I can play with the numbers and get the color. That is something that I cannot make on Illustrator or on Photoshop. See the color that I will get when I send one specific value in multi-channel. We support multi-channel profiles from 3 channels up to 8 channels. And here you have also the totaling that you are getting when you will send this. By default, when you are trying to get this number, you are printing, in this case, 196% of ink. And if you do it manually with free, you are in this case sending 150, so you are saving 46 of ink. This is the ink saving area of the software. Okay, up to here, this is just for allowing you to play with the numbers that you get. So if, for example, we go with one color, for example 34, 27, 28, brown. This brown will be printed in this device with this number, and it's printed quite well because it's 0.5 delta A. But let's go with a different profile. For example, one ceramic profile. This profile here, I'm getting this LAV. And this LAV, even if you try to change the rendering intent, you don't get the close number. Then you can believe that this is the best possible color that you can get on this device when you send this value. But this is not true. Here we have 2 different algorithms of optimizing this color here. If I go with the full and I click and go in this button here, this will try to find a different combination of CMYK values or RGB or multi-channel values for trying to get this color. So it's trying to do the job of absolute colorimetric rendering intent, but in a manual way. The full algorithm takes more time in the calculation, and the other algorithm is going to take less time in the calculation because of the numbers. Here in this device we will see how better can we send to print this value, and let's wait until it's calculated and later we will play. Okay, this is a strange profile because it's a ceramic profile, and we have brown as black, and oh my god, if I send 0000100, I'm getting this LAV that is almost identical to the target LAV, so 0.10, and I'm saving 78 of ink, and by default color management I was getting this value here. So I'm improving a lot my output, a lot. If I do not use this technique and I just relay on the standard colors management, the value that I will get will be this one. And you can check in Photoshop if you take this profile and these values that you get these numbers. But let's play it with something more familiar to you, not ceramic profiles. For example, let's try with C gets condition 6. Okay, this color, it's an easy color. Let's go for one Pantone, and let's go, for example, for the Pantone, I don't know, 3 or 5, 3, 4, for example. Okay, and getting this Pantone quite good, for example, with 0.57, and I will go with the fast algorithm, and I will try to find a better combination for this value. And here I'm trying to reach one LED that is standard because it's a Pantone color, and this is a standard profile, and this is the standard value that I will get with decimals. Photoshop is not going to give you decimals, but this will be the value that RIP will send to print. And let's see which number can I get, and if it's improving or not, and how much ink I'm saving. Okay, I can improve this, and now I will get it with 0.3 delta E instead of 0.67 delta E, and this color will be nicer. In this case, you see, I have to put a little bit more ink, so I'm not saving ink, I'm putting more ink, because if I increase a little bit the number, I will get better result. There are cases in which I need to put more ink, there are cases in which I need to put less ink. So if, for example, we go for a violet, and I try to print one violet, and I try to optimize the value over CMYK, the default value will be 94.51, 100, 3.53. The ink consumption is 198.04, but I can send in 190, so saving 8 of ink, get 11.65 of delta E. So these two violets are more close than these two violets, and by default I was getting 12.15 delta E. I'm arriving to 11.65 delta E, and with this number here. So this is working much better than absolute colorimetric in standard CMYK profiles with standard profiles. But if you go to multi-channel profiles, then depending on the color and depending on the profile, the things can go really in a dramatical point of view. Let's select, for example, this profile here. Of course, if you send this value here, let's click this out. So this will be the default value, and let's go for an optimize. The default value will be this number here that you have, and the delta A will be 8.65. The ink consumption will be 241 when you send 84, 83, 0, 6, 0, 68. Let's see what number can I get. As this is multi-channel, it's going to take a little bit more. Okay, here we have it. If I replace with the 83, 86, 0, 0, 0, 71, I'm getting 7 delta E instead of 8 delta E, so I'm improving 1 delta E, but I'm also saving ink. And if you don't like this number, you can play with this number manually and change. No, I will send to print instead of 71 only 65, because I want to save more ink. Then you will get this value here, and you can look at the colors and modify your settings. Once you have this, you can save this, and you can save this with one name, and you will save it as CCT. So this is for color grade replacement table, so you can load directly this replacement into color grade, and this will trigger from this number to this name, sorry, to this number. If you type one number, for example, if you want to know which is, if you send 100, 0, 0, 0, 0, 100, this will be the color that you will get. If you click this button here, this button will copy this color as input, and then you will get the color that you get through color management. So as you see, for example, this is 6 delta E, 6 delta E. But this color is possible. This color is possible because if instead of putting this number, you put 100, 0, 0, 0, 0, 100, you get this color with 0 delta E. This is because the profiles are not symmetrical. So there are colors that you can improve a lot, and you can save a lot of ink, and that you will print with worst color and with much more ink if you don't optimize the values. This is because these rendering intents were not developed thinking in multi-channel printing or in ceramic printing, in which the shape of the profile is quite different of a standard CMYK profile. But even in a standard CMYK profile, you can always optimize the value. If the value cannot be optimized, then you will get that the color cannot be optimized. So if you got, for example, to 16.4700, so a black. Okay, and I go, let's jump to CMYK, let's remove this, let's go with one standard profile, so 621. This is quite optimized, but if I go with the full optimization of this value, probably I will be able to reach 0.2. It's quite hard to improve, but let's see if I can print this color with less ink, because this number seems to me really high for trying to get this color here. Let's see the full, it's taken a little bit more of time, you know, but let's see what can I get. Okay, no better color found. That's funny. It's no way of improving this color, but manually you could probably arrive to a color that saves much more ink, and it's almost identical or even better something. So you can always try to get colors manually. And this is Color Lab. This is Color Lab. Thank you for watching.